Imagine floating in a metal can, hundreds of miles above Earth, while your identical twin stays behind. This was my reality. I spent nearly a year on the International Space Station, while my twin brother Mark, also an astronaut, remained on Earth. We became the perfect experiment. Same DNA, same upbringing, but one of us in space. Scientists compared us to see how long-duration spaceflight changes the human body, right down to our genes. The NASA twin study was a unique chance to see how space rewrites our biology. We already knew space weakens muscles and bones, but the real mysteries were hidden deep in our cells. Samples were collected from both of us, blood, saliva, urine, before, during, and after my mission. This wasn't just about one or two changes, it was a sweeping look at how space affects the very blueprint of life. Having a genetically identical control on Earth made the data powerful and reliable. This wasn't just for curiosity. It's about preparing for Mars and beyond. If we want to send people on years-long missions, we need to know the risks and how to protect astronauts. Mark and I were proud to be the guinea pigs. The data from our study is now the foundation for future research, helping NASA develop ways to keep explorers safe. It's about making sure the next giant leap is a safe one. The future of human spaceflight depends on what we learned. Our story is just the beginning. Let's dive into what we discovered. Think of your DNA as a library of recipes. Your body only uses some at a time. In space, my body started using a whole new set. Over 1,000 of my genes changed their activity compared to Mark's on Earth. These weren't random, they were responses to space stress, radiation, microgravity, isolation. My immune system genes ramped up, DNA repair genes shifted, and bone formation genes adapted. Most changes faded after I returned, but about 7% of my gene expression stayed altered for months. These space genes are a clue to which systems are most affected and need special care on long missions. Understanding these changes helps us predict and prevent health problems for future astronauts. It's not about stopping adaptation. It's about supporting it so crews stay healthy and mission ready. This research is a roadmap for medical support in deep space. The more we know, the safer we can make the journey. Space changes us at the genetic level, and some changes last. Here's where things get weird. Telomeres, the protective caps on your chromosomes, usually shorten as you age. Everyone expected my telomeres to shrink in space, speeding up aging, but the opposite happened. My telomeres got longer. For a moment, it looked like space was a fountain of youth. Scientists still don't know why. Maybe it's the diet, exercise, or the unique environment, but the effect was temporary. Once I landed, my telomeres quickly shortened even more than before. This rapid reversal is a mystery, and it could mean long-term cellular consequences. The telomere puzzle shows that returning to Earth is as biologically dramatic as leaving it. We don't have all the answers yet, but this finding is reshaping how we think about aging and health in space. The lesson? Spaceflight changes us in ways we never expected, and we're just beginning to understand how. Even in space, you're never alone. Your microbiome comes with you. My gut bacteria changed dramatically on the space station. The balance between major types of bacteria shifted, and overall diversity dropped. A less diverse microbiome could mean higher risk of inflammation or infection on long missions. The sterile environment, packaged food, and isolation all played a role. The good news, once I returned to Earth and ate fresh food, my microbiome mostly bounced back. This resilience is promising, but it shows we need to manage astronauts' gut health on deep space journeys. Probiotics and special diets could help keep crews healthy far from home. Our internal ecosystems are as important as our spacesuits. The microbiome is a key part of surviving and thriving in space. Coming home after a year in space is a shock. Gravity feels alien and your body has to relearn everything. Most of my gene expression, telomeres, and microbiome returned to normal, but some changes lingered for months. About 7% of my gene expression stayed altered, especially in immune and DNA repair systems. These long-term effects are now a top research priority. The twin study was just the start. We need more data from more astronauts to truly understand space's impact. Every mission adds to our knowledge, helping us protect future explorers. Studying the body in space teaches us about human biology on Earth too. The journey changes you inside and out. Subscribe for more cosmic adventures and join us as we push the boundaries of what it means to be human.